Simi Valley is a synclinal valley in Southern California in the United States. It is an enclosed hidden valley surrounded by mountains and hills. It is connected to the San Fernando Valley to the east by the Santa Susana Pass and AMP 118 freeway, and in the west the narrows of the Arroyo Simi and 118 freeway connect to Moorpark and Ventura, California. The relatively flat bottom of the valley contains soils formed from shales, sandstones and conglomerates eroded from the surrounding hills of the Santa Susana Mountains to the north, which separates Simi Valley from the Santa Clara River Valley and the Simi Hills. Geology: Simi Valley borders the Santa Susana Mountains to the north and Simi Hills to the east and south. The valley covers an area of about 62 square miles in southern Ventura County, bordering the San Fernando Valley in Los Angeles County. The Santa Clara River Valley occupies the northwestern corner of the valley. Mountainous terrain of South Mountain and Oak Ridge characterizes the northern and central area. Elevation within the quadrangle ranges from about 250 feet along the Arroyo bottoms to over 2,200 feet. Steep, highly dissected slopes form much of the boundary of the area. In the southeast, Little Simi Valley, drained by Arroyo Simi, Arroyo Las Posas, separates the southern flank of Oak Ridge from the Las Posas Hills. The Las Posas upland area, a broad elevated region that slopes gently to the south, separates the South Mountain Oak Ridge Highlands from the Las Posas Camarillo Hills between Little Simi Valley on the east and the Oxnard Plain on the west. This relatively low-lying area is also referred to as the Las Posas Valley. Numerous north-south trending drainages cut South Mountain and Oak Ridge, creating steep, narrow canyons on north-facing slopes and wide, flat-bottomed canyons with incised streams on south-facing slopes. A network of residential streets and ranch and oilfield roads that traverse the area from U.S. Highway 101 and State Highways 118, 23, and 126 provides access to the area. Current land use includes citrus and avocado orchards, oil well drilling and production, sand and gravel quarries, decorative rock quarries, cattle grazing, suburban residential development, and golf courses. The oldest geologic unit mapped in the Simi Valley quadrangle is the Upper Eocene to Lower Miocene Cesspit Formation. The Cesspit Formation consists of alluvial fan and floodplain deposits of interbedded pebble-cobble conglomerate, massive to thick-bedded sandstone, and thin-bedded siltstone and claystone. In the northern part of the map area, Cesspit Formation is overlain by an interfingers with the Upper Oligocene to Lower Miocene Vaqueros Formation that is composed of transitional and marine sandstone, siltstone, and claystone with local sandy coquina beds. In the Las Posas Hills, Cesspit Formation is unconformably overlain by marine sandstones of the Middle Miocene Topanga group that are interlayered with and intruded by basalt flows, breccia, and diabase dikes of the Conejo volcanics. Deep marine strata of the Upper Miocene Modlo Formation cover the Vaqueros Formation and Topanga group along the crests and southern flanks of South Mountain and Oak Ridge. They also occur as isolated outcrops in the Las Posas Hills. Locally, Modlo Formation consists of interbedded diatomaceous shale, claystone, mudstone, and siltstone with minor sandstone, limestone, chert, and tuff beds. The most widely exposed rock units in the area are the Pleistocene marine and non-marine Pico and Saugus formations that crop out on the southern flank of South Mountain Oak Ridge. Locally, the Pico Formation consists of marine siltstone and silty shale with minor sandstone and pebbly sandstone. The Saugus Formation overlies and interfingers with the Pico Formation and is composed of interbedded shallow marine to brackish water sandstone, siltstone, pebble to cobble conglomerate, and coquina beds that grade laterally and vertically into non-marine sandstone, siltstone, and conglomerate. A local member of the Saugus Formation is exposed in the southwest corner of the map area. It is predominantly a volcanic breccia conglomerate that resembles the Conejo Volcanic's breccia, but is believed to represent remnants of landslide debris shed from the Conejo Volcanics into a local trough during Saugus time. The valley's surficial deposits cover the floor and margins of the Little Simi Valley, Santa Clara River Valley in the north, and Arroyo Las Pozas in the south, and extend up into the larger canyons that drain South Mountain and Oak Ridge. Extensive surficial deposits are also present in the Las Pozas upland area in the southwest. These upper Pleistocene to Holocene sediments consist of older and younger alluvial fan and valley deposits, colluvium, active alluvial fans, and active stream deposits. Pleistocene to Holocene age landslide deposits are widespread throughout the Simi quadrangle, especially in the finer-grained tertiary sedimentary units where bedding plains are dip slopes. In addition, massive slumps are present in the Cespa and Vaqueros formations on anti-dip slopes. Seismic and well data from the San Fernando Valley document evolution of that region from mid-Miocene rifting to north-south contraction. Formations in the western San Fernando Valley subsurface traced southward to outcrops in the Santa Monica Mountains that constrain faulting along the valley's south basin edge. Cretaceous strata in the Simi uplift to the west are over 2 kilometers higher than equivalent strata beneath the western San Fernando Valley across a boundary marked by the Chatsworth Reservoir Fault, a neogen of thinning and offlap. The Simi Fault, located at the eastern end of the Simi-Santa Rosa Fault system, bounds the northern margins of the Simi and Tierra Rajada valleys. West of Simi Valley, the Simi Fault has placed Miocene Conejo volcanics over Pleistocene Saugus Formation rocks. The 15.5 plus or minus 0.8 meters YA base of the Conejo volcanics, identified in oil well logs, is inferred to have a dip-slip separation of about 425 to 550 meters, suggesting a low long-term slip rate of about 0.03 millimeters year. However, substantial late Quaternary offset is suggested by the presence of more than 150 meters of Pleistocene and younger alluvium that fills the east-west, trending, down-dropped bedrock trough beneath western Simi Valley. In addition, trenching within faulted colluvial deposits in Tierra Rajada Valley has revealed evidence of multiple shears within Holocene deposits.